Hello and welcome back to Calculus 1, section 3.10, derivatives of inverse trig functions. So we have 6 trigonometric functions, and you already know those 6 derivatives, I hope, right? And now there are 6 inverse trigonometric functions, which will all also have their derivatives because they have tangent lines have slope, and slope is calculated to derivatives, so they should have derivatives as well. The way you prove these derivatives, if you're interested, you can read in a book, is you actually use inverse functions off of the trig, and then some implicit differentiation. The proof is outlined on page 214. So you can go and look at the proof if you are interested to see in which way these formulas are developed. Now, in terms of use of these formulas, I will note which 2 formulas are used pretty much all the time. The other 4 are very rare. You know, they show up very rarely. So let's write, what's funny? Let's write these formulas down. So the first one is going to be the derivative of inverse sine. So sine minus 1 of x, which would be 1 over square root of 1 minus x squared. And then the next one would be the tangent inverse. You would think cosine. No, tangent. Which is 1 over 1 plus x squared. And then just to finish off this column, I'm going to go with the secant inverse x. And that's going to be 1 over absolute x times the square root of x squared minus 1. So these are the 3. And now you have the other 3. Guys, just copy everything and put minus sign in front. So easy. So what's the derivative of cosine inverse of x? Copy what you have for sine and put negative 1 on top. And that goes for all of these. So you just make the ones negative and just copy everything. So we have the derivative of the cotangent inverse of x is going to be negative 1 over 1 plus x squared. And the derivative of cosecant inverse x is going to be negative 1 over absolute x times the square root of x squared minus 1. So I'm going to put the box over here for these 6 separate them there as well. And I'm going to actually box these 2 as the 2 formulas that are actually showing up most of the time. And if you want the breakdown between 2 of them, it will be inverse tangent about 70% of the time and inverse sine about 30% of the time. There you go. Maybe I should bump that to 75 to 25. Sounds appropriate. When are you going to use these formulas in this form? Never. Because of the chain rule, right? So you are not looking into sine inverse of x. You should be looking into sine inverse of f of x. Now, as soon as you change x into f of x, all of the x's change to f of x's on the other side, and you have to multiply by f prime because of the chain rule. So, what is the modification, let's say, for tangent... Why blue? What is the modification for the derivative of tangent inverse of whatever function f of x? Well, if you look at the formula up there, it says 1 over 1 plus x squared. So the denominator is 1 plus x squared, so this should be f of x squared in denominator, and then its derivative on top. So that's the way you modify these formulas. Each one of those will replace each x with f of x, and then you would multiply everything with f prime because of the chain rule. Good. So finally, what is the derivative of inverse tangent? What is the derivative of inverse tangent of, let's say, x cubed minus x plus 9? Okay, so, well, the formula is right up there. So the derivative of the argument is 3x squared minus 1, and then we have 1 plus x cubed minus x plus 9, everything squared. Done deal. That's it. Let's work one more out. What happened?
You know, the x, keep going with the x squared and just leave it like that?
That's it, yeah, just leave it like this.
Okay.
Oh, you want to square this? Why? We don't need it. Oh, okay, well, here, by popular demand, second derivative. You should see some of the looks you got. So how about the which function should I use out of these 6? Sine? Okay. X sine inverse of of e to the x squared. There we go. Because we can. Hold on. Who else? Who think it's done? So I can go over and say no. It's a product rule. Let's go. You have function x times the inverse sine function. So copy the first derivative of the second plus copy the second derivative of the first, which is 1. I gave you half of the problem already. Okay. It's energy to stay another 3 hours. Finish up chapter 4. Right? So this is a product rule. We are going to do the standard copy the first times derivative of the second. Now derivative of the second is going to be we have square root of 1 minus, and now instead of x squared we have to use f of x squared, which is e to the 2x squared. Yeah. And then the derivative of e to the x squared is e to the x squared times 2x in front. Plus, copy the second, which is sine inverse e to the x squared times derivative of the first, which is 1. So now we can make this just a tag prettier by moving the x there. So we have 2x squared e to the x squared divided by square root of 1 minus e to the 2x squared plus sine inverse e to the x squared. Ta-da! That's that. I hope you're happy. Given how tired you are. Because it's morning, right? Right. Good. All right, lab time.